Okay, so this is lesson 1.4, solving multi-step equations. So in this, it's called multi-step equations, which means there's more than one step to solve it. What we've been looking at were simple equations. These have 2, 3, or more steps in order to solve it. So this very first one, example 1, says solve 2.5x minus 13 equals 2. So just how when we use our PEMDAS, our order of operations, to solve a normal problem, when we're not solving for a variable, okay, we do parentheses, exponents, multiply, divide, add, and subtract. Well, when you are solving for equations, just how when we do the opposite, like if something's being added, we subtract it, or if it's being multiplied, we would divide to solve, you have to do the opposite order. So it means you're going to get rid of the stuff that's added or subtracted first, then multiplied or divided. So it kind of works the opposite direction. Just how we solve everything doing the opposite, we use our order of operations the opposite direction. So when we're solving this equation, okay, we look, here's x, here is my equal sign. So if I cover up the other side of the equal sign, I can see 2.5x minus 13. So I have two things keeping x from being by itself with the equal sign. I have a 2.5 and a 13. If we notice, the 2.5 is being multiplied by x, the 13 is being subtracted. So I'm going to get rid of the one that is being subtracted first because we're using the opposite direction. So since it's minus 13, I'm going to do the opposite and add 13 on both sides of the equal sign. When I do that, I'm left with 2.5x, an equal sign, and then 2 plus 13 is 15. So this is now my new equation. 2.5x equals 15. So again, I'm trying to get x by itself with the equal sign. I have 2.5 being multiplied. So we do the opposite of that and divide both sides by 2.5. 2.5 divided by 2.5 is 1, which is what we want, 1x, an equal sign. And then 15 divided by 2.5 comes out nicely to 6. So all of that, and our answer is x equals 6. Okay, we're going to look at one more example because this one has like terms in it. So this one says solve negative 12 equals 9x minus 6x plus 15. So we've got to solve for x, but we have more than one x. So we first have to get our like terms together. Okay? Or we could go ahead and get rid of the other. It doesn't matter on that which one you do first, okay? They show getting rid of the 15 first. I'm going to go ahead and combine my like terms to 1x. 9x minus 6x is 3x. So that is negative 12 equals 3x plus 15. Okay, so I see to get my x by itself with the equal sign, I need to get rid of this 3 and this plus 15. The 3 is being multiplied, 15 is being added. So you get rid of the one that's being added or subtracted first if there is one. So we do the opposite and subtract 15 from both sides of the equal sign. Okay, so we have negative 12 minus 15. Negative 12 minus 15 more is negative 27. You can check that in your calculator if you're unsure. And then we have 3x on this side. So the last thing to do, because we still haven't solved for x, we have to get rid of this 3 that's being multiplied. You would divide both sides of the equal sign by 3. Negative 27 divided by 3 comes out to negative 9. And then they show you can easily check it by going back and plugging negative 9 in for x. And if you work it all out, you get negative 12 equals negative 12. So you can make sure you did it correctly. Okay, I want you to attempt these 3 problems right here, 1, 2, and 3. So you'll pause the video, try and solve for those variables, and then we will go over them together. Okay, so on these first 3 problems, we're solving multi-step equations. So like I told you a while ago, you're doing PEMDAS basically backwards. So we're going to get rid of the adding and subtracting first, then move up to multiplying and dividing and so forth. So here's n. If I cover up the other side of the equal sign, guys, we have a negative 2 and a plus 3 that we have to get rid of. This negative 2 is being multiplied by n. This 3 is just being added. So basically you're getting rid of the one that's by itself first, this plus 3, okay?
And we get rid of that by doing the opposite. So I'm going to subtract 3 from both sides of the equal sign because we have to keep our equation balanced. So I'm left with negative 2n, this equaled 0, which is what we wanted, an equal sign, and then 9 minus 3, I almost wrote 3, it is 6. So now I have negative 2n equals 6. This is negative 2 times n, so I do the opposite and divide by negative 2. Now, that means divide. If I were to add 2, that wouldn't get rid of just the 2. That would move the 2 and the n across the equal sign, which would cancel it out, and we would be left with nothing over there, and you don't want to cancel everything out. So, negative 2 divided by 2 is 1, which means we have 1 n left. That's what we want. 6 divided by negative 2 is negative 3. So, n equals negative 3 is the answer to the first one. Okay, the second one. Some of you probably went to number 3 and then came back because of that fraction. Those scare y'all. This one did make it a little tricky. So now my letter's on the other side. So if I cover up this side, I have a 1/2 and a negative 11. We're going to get rid of that negative 11 first because it's off by itself. It's minus 11, so we do the opposite and add 11 to both sides. Negative 21 plus 11 is negative 10, and I have 1/2 c. Now, it's 1/2 times c, so we would divide, okay? But if you look at this, we can't have a fraction divided by a fraction because that really means 1 divided by 2 divided by 1 divided by 2. That's a lot going on. So if you remember, when we divide fractions, we flip that second one and multiply. So you do the same here. So we would take that 1/2, flip it, so it's going to become 2 over 1, and multiply both sides by 2 over 1. Well, 2 over 1 simplified is really just 2. So these cancel, and we're left with c equals, because it's 2 over 2, which is 1. Then on this side, we have 2 times negative 10, which is negative 20. c equals negative 20. Even if you didn't get that answer, you should have taken your answer and plugged it back in. Okay? 1/2 times negative 20, well, half of negative 20 is negative 10. Negative 10 minus 11 more is negative 21. It's an easy way to check your answer. Okay, so this third one now, we have negative 2x minus 10x plus 12 equals 18. So in this one, we have 2 x's. Okay, so to solve for x, we have to get it down to just 1. So I'm going to go ahead and combine my like terms. So I have negative 2x minus 10x. So negative 2 minus 10 more. We have negative 12x. Then I still have plus 12 equals 18. Okay, so now I'm solving for x. So if I cover up the other side of the equal sign, I have this negative 12 being multiplied and this 12 being added that are keeping me from solving for x. So I'm going to get rid of the one that's being added first. So I subtract 12 from both sides of the equal sign. I'm left with negative 12x equals 18 minus 12 is 6. I have negative 12 times x, so to get rid of that, I have to divide both sides by negative 12. Okay, a positive and a negative is a negative. 6 divided by 12 just simplifies. It is 1/2.
Okay, now on example 3, if you notice we have some parentheses in here. So this problem, I'm going to show you there's 2 methods, method 1 and method 2, on how you can solve this one. So I'll show you both of those, and then you'll be able to use whichever one you feel more comfortable with. So this first method, since we have 1 minus x in parentheses, we can't solve that. But we have a 2 being multiplied by it, so we can distribute that 2. Remember I told you, distribute, it's like grandma at Christmas time. She gives everybody a present. So 2 goes into everything inside parentheses, which is what they've done here. They just went ahead and did it. They said, okay, so we have 2 times 1 minus, and then 2 times x. Let me see if my little highlighter tool will work. There we go. And then we still have that plus 3 equals negative 8. So our ultimate goal here is we're trying to solve for x, but we can't solve for it when it's in parentheses like that. So now they multiplied. 2 times 1 is 2. 2 times x is just 2x, plus 3 equals 8. So here's my problem now. So if you notice, let me switch. We have a 2 and a 3 on the same side of the equal sign. We can go ahead and combine those by using what's in front of the number. So I have 2 plus 3. That's where they got this plus 5. Okay, so we have negative 2x plus 5 equals negative 8. Now we're going to try and solve for our x, now that we have everything else combined. So I have a negative 2 times x and then a plus 5. So remember, you use your order of operations in reverse because we're doing the opposite of everything. So we have to get rid of this 5 first. Since it's being added, we do the opposite and subtract. So we subtract 5 from both sides of the equal sign so that we can still keep it balanced. That's the whole reason we have to do it twice, because there's an equal sign, so to keep it equal, you do the same thing. So then I'm left with negative 2x because this canceled, equals 0, equals negative 8 minus 5 more is negative 13. So I have negative 2x equals negative 13. So from here, I still have negative 2 times x. So to get rid of it, we do the opposite and divide. Don't try to add this 2. If you add this 2, you're moving the 2 and the x to the other side, which would then cancel everything over here, and that won't do anything good for us. So we divide both sides by negative 2, and we're left with x equals 6.5. Okay, and again, you can plug it back in for x to verify that it does work.
Okay, so on problems 4, 6, and 9, on 4, remember there's two models that you could have used on how to solve this, whichever one's easiest for you. I am going to get rid of my 6 first, and then I'm going to divide to go ahead and get rid of 3 before I distribute. So this 6 is being added, so to get rid of it, I subtract it from both sides. I'm still left with 3 times x plus 1 equals negative 9 minus 6 more. Oh, sorry, I had something in my is negative 15. So now, instead of distributing that 3 in, I'm going to just divide the whole thing, both sides, by 3. And I'm left with x plus 1 equals negative 15 divided by 3 is negative 5. So now to solve for x, we just have to get rid of this 1. Negative 5 minus 1 more is negative 6. X equals negative 6. And you can plug it back in for x to make sure it's true. Okay, on number 6, this time we have 2 y's. So on this one, I'm going to distribute. So this negative 2 is getting multiplied by everything in parentheses. So I have 13 equals negative 2 times y is negative 2y. Negative 2 times negative 4 is positive 8, so plus 8. And then I have plus 3y out to the side. So if I look, I have this negative 2y and this plus 3y on the same side of the equal sign. So I don't have to do the opposite. I can just do what is between them. So I have negative 2y plus 3y. Negative 2 plus 3 is 1. So I have 13 equals 1y, and I still have that plus 8. So now to solve for y, I'm going to get rid of that 8. You could have also gotten rid of the 8 here first and then combined your like terms. I'm going to do that from both sides. So then we have y equals 5. Or 5 equals y, that means the same thing. Just because the variable's on the other side still means the same thing. Okay, and last one, number 9, this one had 2 sets of parentheses and each has a letter in it, or a variable. So I'm going to go ahead and distribute all of this. So this 5 gets distributed into these parentheses, this 2 gets distributed into these. So 5 times 3 is 15, minus 5 times x is 5x, plus 2 times 3 is 6, 2 times negative 1x is negative 2x, equals 14. All right, so I've got several like terms on this one. So I have a 15, I'll box it, and a plus 6 on the same side. I also have a negative 5x and a negative 2x on the same side. Since they're all on the same side of the equal sign, I'm going to go ahead and combine them. So 15 plus 6 more is 21. And then I have negative 5x minus 2 more x. So that is minus 7x equals 14. All I've done is combine my 2 squares here and combine my 2 circles here. I went ahead and kind of did 2 steps in one. Now I'm solving for x. So if I cover up the other side of the equal sign, I still have to get rid of this 21 and this 7. This one is being multiplied This one, there's nothing out here. That's where we know there's an imaginary plus sign, okay? So I've got to get rid of it first. So I subtract it to the other side. I still have negative 7x. 14 minus 21. Let's see. Been a while. Let's see. 1, 6 is 7. Negative 7. Now, I have negative 7 times x, so I do the opposite and divide both sides by negative 7. Well, we already know negative 7x divided by negative 7x is 1x. So negative 7 divided by negative 7 is 1. X equals 1. All that, and x equals 1.
Okay, so last example we're going to look at, example 4, says use the table to find the number of miles X you need to bike on Friday so that the mean number of miles biked per day is 5. Okay, the mean means your average. That's where you add up all the numbers and divide by how many numbers there are. So if we come over here and look, we have Monday, Tuesday, Wednesday, Thursday, Friday. So we have a total of 5 days that we're looking at. So that means if we added these up, whatever number we get, we would then divide it by 5 to get our average. Okay, so it says use the table to find the number of miles X. So we've got to figure out how many miles they need to bike Friday so that the average will equal 5. Okay, so from that, we know if we were to add all of these up and then divide it by 5, it should equal 5. So that's what we're going to set this problem up. And down here, that's what they've done. They show adding them all up. We don't know X, but it's still being added. Divided by 5 equals 5. So we can combine these numbers that we do know. When we add those, we get 14. So we have 14 plus X over 5 equals 5. Now we are solving. To get these on their own, since this is being divided, we would multiply both sides by 5, which is what they do right here, to cancel that on bottom. So I have 14 plus x equals, well, 5 times 5 is 25. Now it is a simple equation. We get rid of this by 14 by subtracting it from both sides, and we are left with x equals 11. Okay, I want you to attempt number 10. It's not as scary as it looks. Use the picture to help you and really try to look at what each variable represents, okay? So you're going to try this one, and then I'll work it out for you.
Okay, so for this last problem, I wrote the formula down and I tried to redraw the picture. Okay, so the problem says the formula D equals 1/2 N plus 26 relates the nozzle pressure N, so N is the nozzle pressure of the fire hose, and the max horizontal distance the water reaches, D. Okay, so how much pressure is needed to reach a fire 50 foot away? So they tell us that N represents the nozzle pressure, okay, from the fire hose. D represents the horizontal distance, the max that the water can shoot. Okay, so we're trying to put out this big fire. So it said what pressure is needed, so what pressure on the fire hose is needed to reach a fire that is 50 foot away. So they gave us 50 feet. We have to figure out if that is D or N. So 50 feet away, they told us that's your distance of how far the water can go. So 50 is what would be represented by D in this formula. And they said, what is the pressure needed? So we're looking for N, okay? So D is now 50, and we don't know N, but that's what we're looking for. Now that we know the distance, we can solve for it. So I have 1/2 and 26 to get N by itself. So I'm going to get rid of this 26 first because it's the one by itself. I do the opposite and subtract 26 from both sides. 50 minus 26, I'm going to kind of scoot it over a little bit, is 24. I still have 1/2 N, and this canceled. I now have 24 equals 1/2 N. So 1/2 is being multiplied by N, so we would divide, but if you remember, can't divide a fraction by a fraction. You flip it and multiply. So we're multiplying both sides by 2 over 1. So that becomes 2 over 2, which cancels. That's 1. 24 times 2 is 48. So we would need the nozzle pressure to be at 48. And I can't remember what it was in. It said pounds per square inch. So 48 pounds per square inch is the water pressure needed for that water hose to reach 50 foot straight and put out the fire.